Hello everyone and welcome to Unacademy classes. And today we are going to do our second class from the topic thermodynamic revision. And in this class, like we did in the previous class, we will be doing our revision via questions mainly. So before starting this class, let me check out if the stream is working properly or not. So let me check it out. So I'm just opening the chat in the mobile app so that I can view that. So the stream is working fine and let's start the class. So once again, hello to everybody and welcome to Unacademy classes. My name is Abhishek Mishra and in this class we will be continuing our revision of the manufacturing subject and this class will be taken entirely by me in English. So if you are comfortable in this language, then you will find this class very enjoyable and engaging. And I will be using simple English so that the students who are not that comfortable can also have a good time here, because the technical terms will be mainly be discussed. So you will either way you are going to study the terms in this technical terms in English only. So I think that this class will be fine to understand. And I have completed my MTech in 2019 from IIT BHU Varanasi. I have secured AIR 662 in GATE 2020, and I've got 2 years of mechanical engineering experience in teaching. And some of my interests are photo editing, video editing, cricket, football, and I like all sorts of games. So since I've prepared for GATE and I've also taught it, so I think I will provide you. You will find a lot of things, a lot of tips and tricks, lot of important details that will help you for your GATE examination. And without further ado, let's first of all discuss about Unacademy subscription and why you should subscribe it as soon as possible and how it will help you. So if you have not followed me on unacademy.com, you should check my profile there by visiting the link that I have provided in the screen. Just write this link on your browser and just visit the profile of mine. There you will be finding free notes, free classes, and you can follow me so that you can get my full schedule there. I will be taking exclusive classes there. The classes such as important questions from thermodynamics, manufacturing, most likely question, top 50 questions. So this type of classes will be held there. So you can check out the class there and just write this code down in your copy so that you can watch free classes on Unacademy app and website. So ABHIMI is the free classes, and this code will first of all is must to watch their free classes. And if you are not having this ABHIMI code, then you can't watch classes for free on Unacademy app and website. So just use this code and you can download notes also if you have entered this code on the Unacademy website. And Unacademy is also providing you subscriptions. So subscriptions for Unacademy subscriptions, I am just going to discuss what it offers. But before that, if you have not downloaded the Unacademy app, just download the app. The app is absolutely free. So just download it, check it out, and you will find that the app is very advanced. You will not find the usual layout and usual interface that I think is needed to be changed, and Unacademy has done just that. They have changed this learning style for the better, and you will find that this app has got all the things that you need for your preparation. So just download this app, explore this app. Since this is free, so there is no harm for just checking it out, and I think you will find it very helpful. So what you will get when you subscribe to Unacademy? So when you subscribe to Unacademy, you will be getting the daily live classes. So from the moment onwards you have subscribed, you can attend live classes which will be held regularly on the Unacademy's app and website, and you can ask your doubts, answer polls all while the class is going on. And live test and quizzes, structured courses, unlimited essays are other things that is provided by the Unacademy uh, subscription. So the subscription, what is how you can buy it, how you can get the subscription for least possible price, I will just discuss all these things in a quick way just after this. But again, tests are very important, and Unacademy's quizzes and tests are traditional quizzes also, and some new type of quizzes also, which will keep you very engaged and which will make you do this quizzes regularly, because they are just designed and prepared in a way that is very engaging. And courses that is occurring in Unacademy, or that is there in Unacademy for you to attend, are very structured. So you will find that a rhythm is created that will help you in your preparation, and unlimited access of content will be there. So not only you will be able to watch the live classes, but recorded classes and this test series all will be accessible to you if you subscribe to Unacademy. So one subscription will give you all this unlimited access. So this is the subscription price for Unacademy, and the subscription prices are very reasonable for the amount of content, for the quality of content, and for the other things, that is the app interface, the app quiz types, and the competitions. So all these things combined, this is very worth the cost that it is asking you to pay. And you can get this subscription price for even less if you enter this code ABHIMI, and this code is the same code which you can use to watch the Unacademy classes, free classes there. So there is some free classes and paid classes. Paid classes will be only accessible to you when you subscribe, but for watching free classes, to get a taste, you can enter this code, watch the free classes. Then if you are resonating with this app of Unacademy, then you can subscribe to Unacademy by one of these plans. So 12 months, 18 months and 24 months plan are one of the best plans, because they are offering a lot of discount here. And if you are planning to give the GATE examination 2021, which is 14th of February, so around 2 months are left. So you should subscribe to Unacademy now, because now a lot of revision classes, not a lot of crash courses are going on. So this is the best possible time for you to subscribe and take benefit from these classes. So the best possible route for you to attend, for you to follow now for GATE 2021, is to subscribe to Unacademy, attend revision classes, crash courses, and give a lot of tests and learn from your mistakes. And also do time management while you are giving tests. Not only just give test and move on, just see how you can do question quickly, see your analysis that is provided by the Unacademy's team, and combining all this thing, you will find that you are going to be very well prepared if you are doing this thing that I have mentioned. So the least possible price in which you can get an Unacademy subscription is this, and the 10% off code is applied, and then only you are getting this least possible price. And there is another type of subscription, Iconic subscription, which are for those students who need more assistance, personal coaching, personalized test series and things like that. So if you need that, then you should go with this, and the same code is applicable here also. So this is the least possible price of Iconic subscription. Again, here are the benefits of Iconic and Plus. After this we will start our class, but again I am pointing this very important thing, that 2 months are left, around 2 months for your GATE examination 2021. So just subscribe to Unacademy and start attending the revision classes, crash courses and test series. These 3 things are very important, and take benefit of all these three things, and do your preparation in a way that you are satisfied. So now let's start our class for the day. So we are doing revision of thermodynamics, and this is our second class. Yesterday's class we discussed a lot of basics, and now we will discuss about the non-flow work. Mainly in this class we will do some questions, and if you have already studied this topic and you are here for revision, then it is very good. You can just sit back and relax, and just listen and take part in discussion of the things that I am going to discuss. Or if you are new, if you haven't studied this, then also this class will help you a lot, because I will be explaining things that I am going to do here. So before doing this, before starting, let me just do one thing here. So let's start the class. I think I have to do it some other time. This video has a lot of blank space, so I thought to just hide it. So anyways, let's continue where we were. The energy of a system can be or can change due to the following three ways, or due to following three ways: work interaction, heat interaction, mass interaction. So yesterday we talked about zeroth law, Gibbs phase rule, thermodynamics, the system boundary, and surroundings, and all the basics. But here we are going to talk about today energy, work, interaction, and mainly the non-flow work or boundary work, which is very important for GATE examination. So we will be doing some questions and learning through that. But before then, we should be doing some prerequisites, some things, some theoretical things, and some formulas we will be seeing that will help us to do those questions properly. So the energy of a system can change due to the following three ways. We have a system that I showed in the previous class. So let me just give you a figure so that you can just view what we are talking about. So we have a system, and the universe which is remaining here, which is not part of our system that we are considering, that is surroundings. And system and surroundings are separated by this boundary. So a system can change, or the energy of a system can change due to work interaction, that is transfer of, or just interaction of the work. And what work is, we will see. Heat interaction, that is heat can be added or removed from the system, that is heat is going to transfer via the boundary. And mass interaction, and the first two terms, heat interaction and work interaction, will be clear to you as we discuss further. But why mass interaction, why the energy of a system is changing due to mass interaction? So energy is a, or energy is an extensive property. Okay, first of all, energy, this is extensive. Extensive property, this means that it depends on the size of what? Size of system. and we can therefore say energy is depending upon, or energy depends on, the mass of system. So energy is depending upon the size of the system, and hence it is depending upon the mass of the system because it is an extensive property. Therefore, the energy of a system can also be changed via mass interaction. Now let's look into what work interaction is. So what work is simply, so work is said to be done by the system if the entire effect of the system on the surroundings can be converted into raising of a weight through the weight may not be raised. So a system is said to do work, okay, and as written in the second part of the theory here in this slide, that the thermodynamics expressions which are standard, or the standard expressions, assume that work which is done by the system, that is work by system, is positive and heat added to the system is positive. So this is just an assumption. So if a work is done on the system, then we will take it as negative because it is opposite of our assumption that we are taking in the standard expressions in the thermodynamics subject. And if heat is added by the system to the surrounding, then we will take it as negative. So this, all the formulas that we are going to learn or that we are going to discuss as moving forward, unless stated, we will take this work by system positive, heat to system positive. And therefore if work is going to be done by the system, then the entire effect of the system on surrounding, that is the system will have some effect on the surrounding, because since the work, since the system is doing work, so there is some energy transfer. So this energy transfer will either make the energy of the system more or less or same also. So this effect of the system on surrounding, if it can be converted into raising of a weight through though the weight may not be raised, then we can say that system is doing work. So this is just a imaginary thing. If weight is also not there, if we can imagine this, that the system is doing some type of work, if there is in imagination also a weight is raised by that effect that is the system is having on the surrounding. So if it is that, then the work is said to be done. So this is just a simple thing, and you can always assume work, or always take work as a force applied on an object and the distance covered by that object due to that force. So force into the distance covered will be the work. Similarly here also it is telling us the same thing, that work is raising and weight raising, and therefore the weight will be covering some distance, so force into distance will be work. But here it is said in some new type of way, and which you should just read it once or twice and just remember, because it may be very it it might come in handy when you are going to give your interviews and stuffs like that. So you have to remember this definition, but don't remember this word by word, just read it few times and you will get what is the gist of this. But the bottom thing is more important for you to remember, that is work done by the system is positive and heat added to the system is positive, and we will look into it as we do our questions here. So the first thing that we are going to do for the numerical, which will come in handy for numerical, is this non-flow work or boundary work or closed system work discussion. So let's do that. And again, if you want to watch free classes on Unacademy app and website, use the code that is shown on the top of your screen, ABHIMI, and try to attend these classes live so that you can answer the questions that I'm asking, and you can ask your doubts all while the class is going on. So what is closed system? First of all, closed system is a system where only energy interaction is taking place. In this system, mass is fixed, so you will not find mass changing. Okay, so closed system, only energy interaction, that is either work or heat interaction can take place here, but no mass change, because again we have talked about the three ways due to which the energy of a system can change: work, heat, or mass interaction. So mass is taken constant here, and therefore that type of analysis will be having this non-flow work, boundary work, or closed system work. So let's look into this PV diagram and let's try to understand what this non-flow work is. So V volume, P pressure, and if you have this system of yours at state 1 and you are taking this system to state 2, so this process 1 to 2, what will be the work done in this process? And we are assuming closed system, so again mass will be constant. So work done in the process 1 2 will be so this is your non-flow work, boundary work, or closed system work. And how this has came to be, since dV, so dV will be a small volume here, so this is dV, and just see what we have done here. Interaction, sorry, not interaction, integration of P dV, P multiplied dV will provide us the area under this curve 1 to 2, and that area is the thing that is provided to us if we are doing the integration of PDV. So this will be for work done 1 2, you will find that this will be 1 to 2, and your area under this 1 2 curve will be provided due to this integration, and that area will be the work done in this process. So area under the curve on a PV diagram represents work interaction for a closed system. So I should write here closed system area under the curve 1 2 will provide you work 1 2 for closed system. So closed system is very important. If we are having an open system, then we will find that the work done will not be first of all called as non-flow work, because there will be flow taking place, so mass will be coming in and going out from that system, and there we will not have our work done equal to this integration of PDV. So only for closed system, only for this non-flow work, we will take that this work done is equal to integration of PDV, that is area under the PV curve of the process 1 2. And the other thing is work interaction is a path function. So work will depend upon path. And why, I have also talked about it in my previous class, but here from this figure you can completely understand why the work is depending upon path, or why it is path function. Because if from 1 to 2, that is from state 1 to state 2, if you have to go, and if you are following some other path, for example if you are following this path, then now your W12 will be changed, because this path will have, let me draw this path very properly here. So this path 1 2 will have a very different area under the curve, and so the work will be changed, and hence work is a path function. So just understand why it is there. Not Do not just learn about it without understanding. Try to understand each of the terms. So the first point should be absolutely clear to you. Area under the curve on PV diagram represents work interaction for a closed system. And if you are not having this thing clear, just look into it like this. So if you are having this pressure P, so let's say a small amount of work del W is done to just sweep this dV volume at pressure P, which is constant. So pressure will be force, or force will be pressure into area into dx. Dx will be the distance which is swept, and area will be the constant. So example, if you have this piston cylinder arrangement, so if you have this piston cylinder arrangement, and if the piston which is having a constant area is going from 1, or going from this 2 to 1, because here the 2 is having more volume, so 1 to 2, going from 1 to 2, and here you can see the area is constant, but the distance which the piston is expanding is changing. So what we will have here, pressure into area will be force, and force into distance, we know that is our work. So I think all of the students who is watching here can, let me just properly write it here. So all the students who are watching here, they know that and you should know that work is equal to force applied on an object and the distance displayed by that object due to that force. So force into displacement is work, and if you don't know that, then just remember that this thing, that force into displacement is work, and force can be written as pressure into area, and area into displacement will be the change in volume. So pressure into change in volume will also give the work, and that's why I have written it like that. So I should write it dV is the volume swept, and here the first term, or the first not term, first point should be clear, that area under the curve on a PV diagram represents work interaction for a closed system, that is for a system where mass is constant but energy interaction can totally take place. Work interaction is a path function. It depends on history, and why it is depending upon history, because if you have changed a system state from 1 to 2 to 3, so let's say, again I am just pointing this again, then that I will be discussing each and every term here so that it is clear, then we will moving on quickly. So why the point is written that work depends upon history, let's see. So if we have this pressure into volume or pressure volume diagram, then if we have a state 1 and due to work it is taken to state 2 and then to state 3. So if, let me again, so if a system is going from state 1 to 2 to 3, then the work done will be different than this 1 to 2. Okay, and if the system will go from state 1 to directly 3 by following this path, then you will say see that the work done is different, even though the initial state is 1 and final state is 3, the area under the curve 1 2 3 and 1 3 is very different, and therefore the work done will be different. So work will not only depend upon the final points, it will also depend upon the path that is followed. So if you are taking a system from point 1 to point 3, then you will have to see that which path you are taking to calculate the work. If you are not seeing which path you are taking, then you cannot calculate the work, and therefore it is to be seen that how we have reached this 3. Therefore work will depend upon the history, and due to the reason that it is a path function and it is an inexact differential, and I have talked about in the previous class, and I will talk again here why it is an exact differential. So when you do this thing of integration of this del w, then you will find that this w obtained is not equal to w2 by w1. If it were to be an exact differential, then this integration would have provided us w2 minus w1 as its value, but this is not the case. Work interaction is a boundary and transient phenomena. That is, work interaction is occurring via this boundary, and boundary will be there because we are changing or we are transferring this work from the system to surrounding, so there will be boundary, and it is a transient phenomena also because it will keep on changing with time. Okay, so here I have to discuss one more thing, that this formula, if you are going to remember this formula, which you should totally, because this is very important formula. So just remember that this is for closed system. So this formula is assuming that the system is closed and it is quasi static. If reversible is also written, then it is a valid assumption there. So quasi static or reversible and closed system are the assumptions that are taken to derive or to just use this formula. So use this formula if these assumptions are given, or if you are using this formula, you need to check out if the system is having constant mass or not, that is if it is closed system or not, or if it is reversible or not. or quasi-static or not. And the other discussion here will be the area enclosed by a cycle on a PV diagram represents net interaction during the cycle. So how and why we are saying this? So here you have a PV diagram. So VP, and here you have a cycle. So you have 1, then 2, and A and B, two processes. So from state 1 to 2 you are going via process 1 A, and then via the part B or process B you are going back to 1 from the state 2. So area enclosed by cycle on a PV diagram will be this is a cycle A B, and this will represents the net work interaction. So I should have written the states like this so that it will be more clearer to you to understand what I was going to discuss. So let's make 1 here, 2 here, process A, process B, and let's break it into 2 points so that we can properly understand why the network is this area under the cycle. So if we only have this 1 2 and process A, then the area under the curve, which will be the work done for process A, will be this area. And it is written on the bottom part that all clockwise cycles on a PV diagram represents work producing devices and vice versa. So engines which are work producing devices that will give work to the surroundings, or the system will do work, will be taken as clockwise. Or we also have talked about that here work done by the system is positive. So since in process 1 2 we are having this clockwise direction, so it is representing a work producing process, so work is produced, so it should be taken as positive. So the area under this 1 2 will be taken as positive, and then we have this 2 to 1 process, that is process B. So area under this 2 to 1 process will be taken as negative because it is anti-clockwise, which is work is to be done on the system in this process. So this is the work that is to be done here in process 2 1 or process B. So if this is positive, this is negative, because again I'm pointing it out, work is done by the system on the or in the process 1 2, that is A, and in the process B, that is 2 1, work is done on the system. So if we take the net of this, then we will find a positive work by this cycle, which is again confirming our point 5 that this cycle 1A 2B 1 is clockwise, so it is work producing cycle, or it is a cycle which is representing engine or work producing devices, and therefore we are having this network as positive in the cycle. And if we just draw this cycle with anti-clockwise direction processes, so if this 1 2 and this is anti-clockwise, then you will say that the net work here is negative. Why? Because this is a work, this work is done on the system, therefore it is representing refrigerators and heat pumps, stuff like that, where work is to be done on the system. So work is consumed by the system to achieve its desired result, and therefore this, why this is negative, you can check it out. So you can check it out by doing this area, by drawing this two processes separately and just calculating their net area. So let's move forward here. So non-flow work in various processes. So this is very important because in today's class, what we will do, we will be doing mainly some questions from the non-flow work processes, and we will talk about some non-flow work processes now. So let's do that. And the first non-flow work process is constant volume. So constant volume process are also called isochoric or isometric. Processes, and here, since non-flow work is equal to integration of PdV, so if this volume is constant, so we will find this as equal to 0, so work will be 0. And this work, again I am writing it down, this is non-flow work or boundary work or closed system work. So only non-flow work will be 0 if constant volume process is there, because again, if no volume is swept, then we can say that our process is not doing any work, or our process, in our process not any work is done. Then we have a constant pressure. Constant pressure processes are called as isobaric. And one more term is there, iso. So again, we will use the same formula, but since here P will be constant, it will therefore be taken outside, and then we will left with this dV. So it will be simply V2 minus V1. So constant pressure and constant volume are quite easy, and you have to again use this non-flow work formula to calculate all this different processes non-flow work. So PdV is very important, and you must remember this so that you can derive all this work. Next we have a very important isothermal processes. So isothermal process are also the processes where, or the processes where T is equal to C, so temperature will be constant. And you can also say that these are hyperbolic processes, because the isothermal process curve will look like, or is a hyperbolic curve, so therefore isothermal process is a hyperbolic process. Why it is hyperbolic process? Because isothermal process, for this we have this PV is equal to constant, so your P is representing y axis and V is representing x axis, so V and P are related by this equation, and which is a hyperbolic curve equation. So let's talk more about isothermal process in the next slide. So again, if we use this relation PV is equal to C in, so let me write one thing. See, for ideal gas, we have this PV is equal to nRT is equal to mR. Here it should be this is the universal gas constant, this is the characteristic gas constant. So let me write it as R dash. So if temperature is constant, then we will find this whole term to be constant. So we will have this PV is equal to C for isothermal, processes, and if we apply, or if we use this equation here, and if we convert P in terms of V, so that we can derive this work done in isothermal process, then we will find that this work will be C ln V2 divided by V1. And let me write it properly because this is very important, and I will write this two forms of equation, one in form of pressure and other in form of volume. So W is equal to, for isothermal work, C ln V2 divided by V1 is equal to C ln P1 divided by P2. And you can find this very properly by just using this PV is equal to C and this W is equal to integration PdV, and you can find this work. And what is C? C will be either P1 V1, P2 V2, or NR T2, or NR T1, or MR dash T2, or MR dash T1. So this one of this things you can use, one of these expressions you can use to calculate C, and this all the expressions will be constant because your PV is constant for isothermal process and your temperature is constant, and since this is a closed system, your mass will be also constant, and your R is constant for a given amount of or it is the first of all, the universal gas constant is always since its name is constant, it will be always constant, and the characteristic gas constant will be same for all the same gases, same type of gases. So you will find that this equations written for C will be constant. So you will have this volume and pressure changed, and if you know these values, you can find this isothermal work done. And this is hyperbola. Why? Because I have talked about it. It is C by V. This is in the hyperbolic form curve. So hyperbolic. And let's add one more slide where we can discuss some other non-flow work that is left here. So the other non-flow work that is left is adiabatic process, and let's talk about it. For adiabatic process, and other is polytropic process. So let's talk about it here only, because I don't think that I have selected one question for adiabatic process. So let's do one thing. Let's talk about this adiabatic process and polytropic process in our next class. And here what we will do, we will do the questions for the process that we have studied today. So let me just delete this slide. And here I will also mention this very important thing, that this work done formula can only be used if you are having this closed system ideal gas, because of this PV is equal to nRT or mR dash T, that is for the closed system and ideal gas. And one more thing is quasi-static or reversible. So quasi-static, reversible. So if it is these things are given, assumed, then you will get this work done as equal to the formula that is written here. Now let's do some questions. These questions are very good questions here. Some of the potential mistakes uh, a student can do, we will also discuss that, because again a lot of you can make some very silly mistakes here if you are not reading this question properly and not fully aware of the things that I have talked about. So let's do this question. In a constant temperature process, 100 moles of an ideal gas at temperature 300 Kelvin attains a volume V2. Work input during this process is 249.42 kilojoule. Initial volume V1 of the gas approximately satisfies the following relation. So you have this four options and you have to find the relation between V1 and V2, and it is first of all given that constant temperature process or isothermal process is there. So isothermal, and 100 moles of an ideal gas at temperature 300. So temperature will be always 300 because it is constant, and the final volume, so we are going, so we have this PV diagram, and we are going from 1 to 2, and T is going to be same, constant, and you have your final volume V2 obtained after doing this process 1 2, and work is given as input here. So if work is given as input, then you can just see that since work will be done on the system, so we have to take this. So what will happen, your system volume will just go up, because here the system will expand due to work being done on it. So system will not expand, but it will, if you consider the piston and cylinder analogy, then it will compress due to work being done on it. So let's draw according to that, because it is given that work is done on the system. Work is here, work input is provided. So T is equal to C, and work input is 249.42 kilojoule. So for constant temperature process, we know that work is C ln, and it is V2 by V1, and V input will be minus 249. So work done will be minus 249.42, because this input means your work will be minus 249, because this is given work is done as work done on the system, and your C will be N R T, and then you will have ln V2 divided by V1. So this will give you the minus 249.42, and it is in kilojoule. So we are taking this R value 8.314, which is approx value. It will be taken with the unit kilojoule per kilomole. So here one of the mistakes people do, it is kilojoule per kilomole. So let's use that R value 8.314, and therefore we have to convert this mole into kilomole. It will be 0.1 into 8.314 into 300, and it is coming as 249.42. Then we have ln V2 divided by V1. So this will cancel, and it will come ln V2 by V1 will come out as minus 1. So this minus 1, if we just remove the ln, we will find that V2 by V1 is becoming equal to 1 by E. So V1 is equal to E V2. So the second option is the correct one. So here the one thing that you have to be very careful about, where you can make this potential mistake, is that this work is given as input, so it should be taken as minus. If you are not taking this work as minus, then what you will get, you will get this ln V2 by V1 equal to 1, and therefore you will get this second option as your calculation. That is the wrong one, because here work input is 249.42. So work input means work is done on the system, and we have talked about it that when work is done on the system, then it should be taken as minus, and therefore you have to be very careful about this. And so just take this minus, and be one more thing, take very careful about that, be very careful about, is that the moles here should be converted into kilomoles, because your value of R is 8.314 kilojoule per kilomole divided by Kelvin, and R value is also 8.314 if we are taking joule, but the bottom term will be then mole instead of kilomole Kelvin. So these two things are very clear to you, should be very clear to you, so that you are not going to do this mistakes, that work input take it as negative, and 100 moles convert it into kilomole if you are using it with R, which is having a kilojoule in it and a kilomole in it. So for today we have this 1, 2, 3, 4, 5 question left for the day, and since I am not having a lot of students watching me right now, so what I will do, I will continue this class tomorrow. We will continue this, and we will end this class today, because I don't think that a lot of students are watching. So we will just continue our class tomorrow. So tomorrow you can watch this class live at 7 p.m. and after that I think I will change the time a little bit, because this time I don't think a lot of you are watching and a lot of other classes are also going on. So we will look into that. So that's it for today's class. You can follow me on unacademy.com to find all the notes that I am using here to teach you, to find exclusive classes where I will be doing some important questions, and just write down this link and just go there, click the follow button to start following me, and download the Unacademy app if you haven't. Use this code to watch free classes on Unacademy app and website. ABHIMI is the code. And if you found this video helpful, then hit the like button, subscribe to this channel, hit the bell icon for notification, so that you are going to get this notifications whenever an educator goes live, and use this 10% off code to get this Unacademy subscription in the least possible price. So this is the code, again the same code, ABHIMI. So let me check if I will, so just keep an eye. I will just look into if I can take the class tomorrow at some other time. I will do that. And so that's for today's class. Thank you for watching. Best of luck for your preparation. Stay safe, take care, and that's it for today's class.